Every model you have ever trained, every single one, is secretly solving one equation. Watch this line, hunt for it. That snap is the equation ax equals b. By the end, you will solve it with your own hands. Watch it fail in exactly two ways and see why that snap is what training really is. Forget solving for a second. Read this as a RUL x plus 2y must equal 8. Every point on this line obeys it, and only these points. A second rule draws a second line. A system of equations is just several rules that must all hold at once. Both rules at once means on both lines at once, and two lines that cross do it in exactly one place. Check it. 2 plus 2 threes is 8. 3 twos minus 3 is 3. Both rules satisfied by one point. That is what solving means, finding the place where every constraint holds. Your phone right now, each satellite says you are exactly this far from me, a circle of possible places. 2 satellites, 2 crossings. 3 satellites, O any point. That point is you. GPS is nothing but solving a system of constraints every second you walk. Now the machine method, write the system as a grid of numbers, and before anything happens, place a bet. We are about to change both rules completely. Does the answer move? Lock it in. One move, subtract 3 of row 1 from row 2. The x's cancel, and watch the picture. The cyan rule pivots into a flat line, y equals 3, but it still passes through the same point. One more move and the green rule snaps, vertical, x equals 2. Both rules are gone, replaced, and the point never moved. If you bet no, you win. Elimination does not change the answer. It redescribes the same point with simpler and simpler rules until the rules just say the answer. A detective with 2 clues combines them to cancel a suspect out of 1 clue entirely. The mystery does not change, it just gets easier to read. Row operations are exactly that: cancel a variable, keep the answer. But what if the lines n never cross? There are exactly 2 ways this fails. A crossing is not guaranteed. Case 1, the healthy one. The lines cross once. And episode 1.4 told you how to predict it. The determinant of the coefficients is not 0. Case 2, make the rules contradict. X plus 2y equals 8 and equals 4. The lines go parallel. No point can obey both. The determinant just hit 0. Case 3, make the second rule a copy in disguise. 2x plus 4y equals 16. The lines lie on top of each other. Every point on the line works infinitely many answers, which is its own kind of failure. Determinant 0 again. 0 cannot tell you which failure, only that the single clean crossing is gone. Now the twist. There is a second way to see this equation, and it explains why it just failed. Same equation, second picture, and this one pays off everything. Read A by its elements, 2 arrows. And B is not 2 rules anymore, it is a target. Solving asks, how much of EACH arrow do you mix to reach the target? Take 2 of the green one, then 3 of the cyan, 1 tip to tail, and it lands. Exactly. X and Y were never a location, they are the recipe, 2 parts green, 3 parts cyan. And now the failure case makes visceral sense. Make the columns point the same way, and no matter how you mix them, tip to tail only ever slides along ON line. Your reachable world collapses from the whole plane to a single line. A target of that line is simply unreachable. That is what determinant 0 means from this side. The world your matrix can reach has shrunk. How much world a matrix can reach has a name, rank, and it is the whole next episode. Now the real world, 20 rules, 2 knobs, and no exact answer at all. Back to the opening. 20 data points. A line has only 2 knobs, slope and height. 20 rules, 2 unknowns, an overdetermined system. No line passes through all 20. Ax equals b has no exact solution. So change the question. These red bars are the errors, how far each point is from the line. Do not demand 0 error. Demand the smallest total error. And here is the miracle. That best line comes from an exactly solvable system, the normal equation. Multiply both sides by A transpose and 20 impossible rules become 2 solvable ones. Solve it and watch the snap. The error meter just fell to the minimum. No other line beats it. This is regression. And every neural network you have ever trained is doing a giant bent version of this exact snap. Minimize the error because the exact answer does not exist. One last secret, if you watched the last episode, everything A can produce lies on this line and B floats just off it. The best fit is the point on the line closest to B. Drop the perpendicular, that is a shadow. Least squares is the projection from episode 1.5, wearing a trench coat. The whole season is one story, 5 lines. Solve gives the exact crossing when it exists, and LSTSQ is the snap, the best line through noisy data. The full notebook is in the description. The map, vectors, transformations, composition, the determinant, the dot product, and today the equation they were all building toward. Ax equals b. You are here. What it buys you. Solving is finding the recipe of columns that reaches the target. Determinant 0 means the columns collapsed and the reachable world shrank. And when no recipe is exact, training takes the shadow, the closest reachable point. That is what fitting a model I is. Next stop, your data has fewer real dimensions than you think. Rank how much information is actually in your matrix. Next, your data has fewer real dimensions than you think. Rank is how much information is actually there and why tiny adapters can fine-tune giant models. Thanks for watching and keep exploring. Next time, rank and the 4 subspaces. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.